Hello everyone. Today we'll be looking at radiation. So what I want you to do right now is to get a piece of paper, a pen, a ruler, a graph paper, and we will begin. Now you can write down your answers on a piece of whiteboard and then you can check after the answer is given. Now the first question here says, state where the house is losing the most heat. Now, if you look on the diagram, you'll notice an array of colors, more so blue, green, orange, yellow, and red. The instances where there are more red indicates where more heat is lost. So you can see that a lot of heat is lost through the doors and the windows. Now, if we were to identify the color which represents heat loss, it will best be described as red, infrared radiation. The more the colors tend to blue is the lower the temperature. The more it tends toward red, the higher the temperature, so it represents the amount of heat lost by an object. Now, this developing question here states that the police now use heat cameras to follow people in poor visibility. Explain how they do this. Well, they can use an infrared gun that is pointed at the individual and the person's heat signatures will be highlighted. So even if you can't see the person physically, you can see them by their heat signature. The keywords that we're focusing on today are conduction, convection, and radiation. Now, radiation, as is our main focus, represents heat transfer by waves, which normally takes place in a vacuum. Now, in order for us to achieve our objective, we need to be able to state the name of the wave which transfers heat and describe which types of surface are better at absorbing or emitting heat than others. Understanding radiation. Now, the question here says, which parts of the earth are giving out the most heat? And if you look on the diagram on your left, you could postulate that it's somewhere over where the land is. So you find that it's the land and the sea. Is water hotter than land? And the land is hotter as it has a brighter color on the infrared image. Now, why do clouds give out less radiation than you would expect from their temperature? Well, clouds give out less infrared radiation because they reflect solar radiation, which is ultraviolet rays. Now, if you were to explain how this picture could be used to justify why the melting of the ice cap is a problem. Now, to complete this task, you just need to write it down in your books using the correct terminologies. Pause, complete the task, and then come back and check your answers where you can self-assess. Infrared radiation is thermal energy that is given off by all objects. Infrared radiation does not require particles to transfer energy. Hotter objects give off more infrared radiation than cooler ones. Now, a simple practical task that you can do to investigate how different colors and surfaces of an object affects the emission of infrared radiation, right? Now, the question that we have is, which surface do you think will emit the most infrared radiation in 1 minute, and describe why? Now, there are 4 different surfaces: your matte black metal can, the shiny black metal can, the matte white metal can, and the shiny silver metal can. Now we're going to make a list of all the practical equipment that we'll need. So we'll need the matte black metal can, the shiny black metal can, the matte white metal can, the shiny silver metal can, an infrared thermometer, a kettle, a heat-proof mat, and a 250 ml measuring cylinder. And you can answer this question. Describe the importance of all cans being the same size and shape. And of course, it's always to make sure the test is fair. So we must keep the size of the container and the shape constant. So we're creating a control. Now, you are expected to order the steps into the order they should be performed. Identify the independent and dependent variables in the method. So pause and put them in order, and then you can check to see if you've done so correctly. So here we go. Number 1, choose a color or surface texture of a can and place it on the heatproof mat. Number 2, measure 200 ml of hot water in a measuring cylinder and pour into the can. Number 3, place the lid on the can, then wait for 1 minute. 4, place the infrared thermometer 5 centimeters from the can, about halfway up, and measure the temperature, then empty the can safely. And 5, repeat steps 2 to 4 twice more for the same can and calculate an average temperature for that can. And finally 6, now repeat the whole experiment for the other cans. And the independent variable, of course, is the surface color of the metal. And the dependent variable is the temperature of the metal can. Now you will have the results done for you. So you need to just draw the following results table on your sheet, and you can plot a graph to represent what is being shown. On your x-axis, you will have the surface, and on the y-axis, the temperature. And this is going to be the mean temperature that you plot. Now, in this task, we're going to ask you to fill the gap by using the words provided. So go ahead, pause, and then check your answers after. Self-assess. So here we go. Hot objects transfer heat by radiation in the form of infrared radiation. Radiation is the only way heat can be transferred through a vacuum. And of course, dark surfaces emit the most radiation, but shiny surfaces reflect radiation. Now, the question that follows says, explain the risk to the body if too much infrared radiation is absorbed. And that is something that you could research and answer. Well, of course, it can damage, burn, kill skin cells because it heats up the cells.